example. Of course, you could up the bandwidth to 5 meg, do different analysis. Come talk to me after the break. Talk about it more. In terms of how this works, 1 gigahertz wide radios delivering up to 100 megabits to the home. There's an outdoor unit that gets installed on the roof of your household. Coaxial cable that splits, connects to your set-top box for satellite TV, and connects to a residential broadband gateway to deliver the bandwidth we want. It's a high-capacity downlink using the 12 or 40 gigahertz frequency. And what we do is we integrate the solution with whatever return path you already have deployed, and if you don't have return path deployed, we integrate that for you. So if you have a network that's rolling out or rolled out a fixed wireless access on WiMAX, and you're only getting 2 meg as an operator, but you want to boost your ARPU and get down to 20 or 30 or 40 megabits per second, then you use this technology to offload your WiMAX network and keep your WiMAX network as the return path, thereby able to deliver 40 meg down and 8 meg up or 5 meg up. Okay? Which is a really good quality VDSL service, delivered wirelessly. We also integrate with different multiple return paths. It can be C-band in areas where, Wi-Fi, as Bill was referring to earlier. It can be 802.11n return paths in areas where there's no interference. If you have existing copper, for example, in parts of the United States, for example, then that copper is only delivering 1 meg. You can use that copper and offload the download to the 1242 gigahertz spectrum. We also have the ability to integrate with 3G and LTE and TD-LTE return paths. So in areas where you're planning to use 800 megahertz spectrum or 700 megahertz beachfront spectrum to roll out LTE services in rural, but you want to boost download for enterprise, for example, you could integrate that with the existing LTE rollout or planned LTE rollout to use that as return path. I'm going to skip this slide, but I think one of the things that's key is the technology allows you to roll out multiple services, not just IP bandwidth, but you can also transpond satellite television content. So if you're talking about a video headend that has your either satellite backhaul or your fiber backhaul, we then transpond the content and multiplex the IP connectivity and broadcast that into the single sector. We're using the same technology. Coming with the system is, one of the things when we're talking about rolling out effective triple play is about how do I get the content? How do I source that content? How do I do it legally, for one, in a way that doesn't sort of infringe piracy laws or content piracy laws? So how do I have digital rights management on that content? How do I do conditional access on that content once I broadcast it? This is all embedded. This is thanks to the work that we're doing with Bluwan, which has a lot of experience in this field. Same thing on the voice over IP, because obviously we're rolling out a system that can do triple play, so voice over IP is an option. You need to make sure that your OIP applications have PSTN integration, handle session border control for network security, local call routing, all these things that need to be, and interconnect agreements for your roaming. So, for termination, excuse me. So, with the Globecom Bluwan system, those things get integrated. Your content, your voice over IP, your SIP, your SDP, as well as your IP connectivity. To give you a look at what it kind of looks like in the field, you have your fiber connectivity at the tower side or the hub. You've got different sectors, 90, 120 degrees, or even on the antennas. You can essentially cast and light up an area with 2.5 gigabits per second of throughput. And if you have line of sight issues, you can use any high point as a relay that's receiving any bandwidth. So you drop off bandwidth, and then you continue relaying that bandwidth to somewhere else. Now, in terms of range, which is probably what some of you are thinking right now is, in those kinds of frequencies, what kind of range are we achieving? So in the 12 gigahertz frequency space, we're averaging in tropical zones, like where we are today, zone N, we're looking at around 10 kilometers of radius, which is pretty much, pretty significant achievement in that frequency. Of course, it's lost, but at the end of the day, we use the relays to go back and hit the masked areas. If you narrow the sectors, if you use 45-degree sectors, you can move that to around 13, 14, 15 kilometers. And if you narrow it down to point, of course, you can achieve up to 50 kilometers. So the technology can be used to trunk, do the middle mile, but also distribute by opening up the sector. This is assuming a 4 nines availability, so you can increase the distance and increase the throughput if you're looking at residential access, maybe you're not providing 4 nines, maybe you're providing 99.97 or 95. Okay, 3 nines. From an architecture perspective, you use the satellite TV as the feed for the television. You can even integrate terrestrial broadcast TV. You got your fiber connectivity. You centralize that through the router and use multiple modems to scale up the capacity to 2.5 gigabits per second. And then it's transferred to your hub radio, which then transmits this to multiple customer premises equipment dishes. And these dishes connect to a set-top box and a residential gateway, which delivers the IP services. To give you an example of what this equipment looks like, what you see on the left is a 22 centimeter flat panel 12 gigahertz antenna radio, weighs around 600 grams, very easy to install. And that connects to the device you see on your right, which is your home residential gateway, delivering 100 megabits per second baseline, right? And then you can scale that up to 200 megabits per second if you add a second modem. So we're talking about future-proof scalability to meet the demands of your customers or your operators' customers for the next 5-10 years to come. Thank you. So I'm almost wrapping up. This is the hub side equipment. You got a low power 30 dBm radio, the 12 gigahertz. We've got omni antennas, sector panel antennas with different configurations. This is to give you an example of what this looks like in the field. We've done some work with Locom and we're piloting this system in the Bahamas. I won't name the operator for confidentiality purposes, but at the end of the day, what you're seeing here is a 12 gigahertz sector, which is providing coverage to pretty much half the island of Nassau. And then what we're doing is we're seeing that around Paradise Island, which is where all the cruise ships terminate and sort of dock and board, there's a lot of increased bandwidth usage. So we're overlaying that with a 40 gigahertz hub, which basically multiplies the total capacity provided to the island to 5 or 6 gigabits per second. With 5 or 6 gigabits per second in hand, imagine what you can do. We were talking about delivering, in the past 2 lanes to a cruise ship. Now you can suddenly deliver multiples of 100 megabits per second without thinking. This is a new development also in the Bahamas, and this is to give you an example of how this can be used to bring connectivity to areas where there are none. There's a fiber drop-off point around where you see the nexus of the red sectors, and that's where we have the fiber drop-off point. After that, for the capitalization across the island, we open up 2 sectors, 12 gigahertz. They have a 10-kilometer range each. And we have a blind spot basically around this part of the island, right here. It's on a ridge. So we have a relay that has line of sight visibility to this part, and all it does is simply re-emit that capacity on that other end of the island. Okay? So to summarize on the performance, military-grade technologies, high availability, high amount of frequency reuse, you are not going to run out of capacity on this network. Okay? 2.5 gigabits per second per sector, scalable up to 20 gigabits per second on a single hub. 100 megabits per second guaranteed to the home. 4 nines availability in end zone, which is where we are right now, or where a lot of these sub-Saharan African countries are. And no trenching or civil works required, so your time to market is weeks and months versus years. Small outdoor equipment, 18 to 20 centimeter dishes, so no visual pollution if you're thinking about resorts or if you're thinking about high-end areas. Small radios, so very low energy footprint. We're talking about 1 watt radios and extremely low electromagnetic radiation in those frequencies. This is an example of what it looks like installed. This is with a WiMAX return path. And typically what we're seeing is an ROI for an operator of 2 years with a cash flow positive time frame of 1.8 years. I've got rain fade charts if you guys want to see what they look like for your region. We can talk about it later. So to summarize, this is a new technology using points and multi-point architecture in the 12 and 40 gigahertz frequency bands to deliver multi-gigabit capacity and next-generation networks in areas where fiber cannot be delivered for economic or geographical reasons. We'd be happy to discuss this with you and look at what part of the spectrums you need to work with as a regulator. And we also have a dedicated regulatory workshop planned at AfricaCom on the 8th of November of this year that will be looking at what you can do with this and what the business case will be to regulators, operators, and consumers. Thank you.